All right, hello, ladies and gentlemen, and welcome back to Monday. And we're going to start something again that's a bit new. So, today we're going to talk about parabolas. And I know that we've talked about this stuff before. We did this back when we did our quadratics unit. So that way I know that you guys know what a parabola looks like. As of right now, you guys know that they're up like a cup or they're going to be down like a frown. What we're going to talk about here is we're going to be getting into what are called conic sections. And our conics that we look at are going to be parabolas, ellipses, those are the ones that look like an oval, circles, I think you know what that looks like, and then what's called a hyperbola. So we'll be working on this stuff over basically for the course of the next couple weeks. Again, this is going to be, we start a little bit slow. We're going to talk today about parabolas in a standard form. Tomorrow we'll look at them, we're going to shift them, and then we'll do the same thing with ellipses, and then shift them, circles. I'll probably hold off on circles actually. And then we'll get to hyperbolas, and then we'll talk about how do you write the equations. We'll kind of mix all that all together, and then towards the very end of this stuff, this might actually be 3 weeks worth of material now that I think about it. We're going to get into what's called standard form of a conic to figure out what shape it is, and this is where the skill of completing the square that we did way back in October, maybe, when we did that stuff was where that's going to come into play. So let's take a look at our parabolas. For right now, we all know that we have something that looks like this, y equals x squared. And this is the form that we've looked at in the past, where it's ax squared, where the value of a was just kind of a multiplier. If the a value was positive, you knew it was up like a cup. If it was negative, it was down like a frown. That has not changed. What changes here today is that there's actually some other parts that are here. When you have a parabola, when we have a parabola, I'm just going to kind of highlight this over here. When you have this parabola, there's always going to be what's called a vertex. We know where the vertex was. We were able to figure that stuff out before. It lies on an axis of symmetry. That was when we did that AOS. Well, what happens is this vertex always looks at what's called a focus. And then this distance has a backwards distance from here to here to what's called a directrix. A directrix is an imaginary line. Let's see if I can draw this a little bit better here. Here's your vertex, focus, and then there's this directrix. This thing that's called a directrix is this imaginary line that is always behind the vertex, okay? Now, depending upon whatever this value is, this distance from vertex to focus is the same as it goes from focus to directrix. So if this distance was 2, this distance was -2 because it went the other direction. As we get into it, there'll be ways of figuring all this stuff out and solving for it and whatnot. Now, one thing I always want you to remember is that no matter what happens here, and this is going to be kind of the big thing as we get going into this shape here. I'm going to group this really fast. Hopefully this will work. As we know, it didn't all go. Oh. Let's try that again. Oh, well, anyway. So what'll happen here is this parabola always opens and it looks at its focus. Remember, think of this, you always want to focus at something. You want to focus your attention as to what's in front of you. And then behind it is the counterbalance, is what's the directrix. So anyway, as we get into this stuff, there's going to be our turned sideways parabolas. Now, the one we started with, this was your y equals some x squared value. And what happens now is if we do an x equals y squared. So what I did is I just took the graphing calculator real fast, and I graphed in the graph the y equals. I did y equals positive square root of x, and y equals the negative square root of x. Basically, think of it this way. I was solving for, I was getting y by itself to do this. Same thing will happen. The vertex, there's a distance to a focus, and the opposite distance goes back to its directrix. How do you figure all this out? Well, the formulas are going to change ever so slightly. Now we're going to write this like this, where if you have an x squared parabola, and it's pretty obvious that if it's an x squared or a y squared parabola, because you'll see the x squared or you'll see the y squared. The generic form is going to be 4py. Well, this value here, this 4p, tells you the direction. If this value is positive, we know it's going to be up. If it's negative, it's going to be down. Whereas the same idea is if it's a y squared, it's going to either open up to the left or it's going to open up to the right. So here's what it looks like. It opens to the left or it's going to open to the right. If this is positive, it opens to the right. If it's negative, it opens to the left. It's going to be really easy to work itself through. So here's the important piece. This value of p. This value of p is always going to be the distance from the vertex to the focus. And how we figure that out is a lot of times is going to be just some real simple counting. Today, our vertices will always be lying at the origin. I'm not moving anything around yet today. So let's look at an example of how this goes. Oh, real fast. This wouldn't be the world's worst thing to have in front of you if you want to write that down. For today, this is going to help us figure out where your focus is located, where the directrix is, what's your axis of symmetry, and so on. So if it's an x squared equation, it means it's either up like a cup or down like a frown. So your focus, the ordered pair, is always going to be 0, comma p. The directrix is always y equals negative p, so that means it goes left to right. And then this was x squared, it goes up and down. And when we draw the directrix in, we're always going to draw it as a dotted line just because it's technically there as a balance point. So let's look at an example. So right off the bat, we have x equals negative 1/6 y squared. So what I always like to do is if this is an x squared or a y squared parabola, I always put the y squared or the x squared stuff on the left-hand side. And then I move, oh, I'm sorry. I was thinking of a different problem. Nope, leave it like that. So what we do is we first identify, is this an x squared or a y squared parabola? Well, obviously this is a y squared parabola, so what we want to do is we're going to write out the formula for it first. So I got ahead of myself. So we know the formula for this is y squared equals 4px. So what we want to do is we want to get the y squared on the left-hand side. So we're just going to rewrite it real quick. Negative 1/6 y squared is x. Now what I want to do is got to get the y squared by itself. So in order to do that, we just have to multiply both sides by the negative 6. So we get y squared is negative 6x. Okay? So how do we figure out what's going on? Well, we know it's a y squared. We know that it's a negative value here. So that means it's got to open towards the left. So I'm going to leave a little note there. What we do is we need to figure out what this value of p is. Well, right now the 4p is being played by the role of negative 6. So what we do is we say 4p equals negative 6. So that means it tells us what our p value is. It's negative 6 over 4, otherwise known as negative 3/2. So how do you graph this, you were wondering? Well, we know that we do this, we're going to do a rough sketch. We know that our vertex is at the origin. I know that my p value is the distance from the vertex to the focus. Well, the distance there is at negative 3/2, so that's 1, 2, it's right here. It's got to open this way. Not really too worried about how wide or how narrow this opens for right now. I'm not even just doing a rough sketch. Now, since the focus was this way at 1.5 to the left, that means the directrix has to be 1.5 to the right. So your focus, your focus was at negative 3, 2, 0, and then your directrix was at the line x equals 3/2. And that's kind of what we're looking at for today. We're trying to just set this up to make it work, all right? Let's try another one. Let's change this. We just did a y squared. I'm just rewrite this as an x squared. So we'll say this is y equals 3/4 x squared. Let's change this up real fast. So if we do that, we wind up doing getting the x. We know it's x squared, so it's either going to be up or down. So we want to move it so that the x squared is on the left. And then we write out our generic form. X squared equals 4py. So I have to move the 3/4, so I have to multiply both sides by 4/3. And I wind up with x squared equals 4/3 y, which means that the 4/3 is playing the role of 4p. Now, in order to figure out what the p-value is, we multiply both sides here by 1/4, same thing as dividing, and we get 1/3 for your p-value. Now, p is positive, it's x squared, which means it tells you has to be moving upward. So once again, don't worry about graph paper. Rough sketch. We know all of our origins, or all our vertices will be at the origin today. 1/3, we'll call it about here. So our focus is at 0, 1/3. Our directrix will be at 1/3 below it. Oops. Sorry, must have bumped something. There's my arrow, and it just opens up. So it's at y equals negative 1/3. Okay. Remember, the whole idea is this distance, the distance from the focus to the vertex is the same as the vertex to the directrix. That will always be the same distance. Let's skip ahead on some of these. Then the other bit that we could do with this is if you're given, since everything's written at the origin today, and that's kind of what we're keeping with, what we want to do is figure out how do you write the equation in standard form given like a directrix or given the focus. So what we want to do is we just kind of rough sketch it so we know which direction it's going. And after you do a few of these, you'll start to realize that it's kind of the same similar questions you're going to ask over and over again. We know as we start that our vertex is at the origin, and if y equals 2 is where my directrix is, I would graph that. Like that, okay? So if that's my directrix, that tells me that my parabola has to open away from it. Remember, whenever you have a directrix, that is behind, it's behind the vertex. So the focus has to be here. If this is 2, this is 2. So this moving downward meant that our p-value is negative 2. By this one opening downward, it also knows that we opened it downward is because if the y value is the directrix, that means it has to be an x squared. So we know that our x squared equals 4py. Well, we know what p is, so x squared is 4 times negative 2 times y, which is negative 8y. And that's where we get this equation from. Okay? Works the same way if you're given, if you're given a directrix of negative 1 for at x. Same thing. Today where all of our vertices will be at 0. If my directrix is at x equals negative 1, that's a vertical line here, that tells you right away that your parabola has to open to the right. It's going to move away from the directrix. The directrix, think of it this way, the directrix wants to go through both sides of the parabola, but it can't because it's behind it. It's kind of an easy way to remember that. And this distance here was negative 1, which means this distance here has to be positive 1, so your p-value is positive 1. Again, since it moved to the right. So y squared equals 4px. Well, p is 1, so your answer is y squared equals 4x. Now, what I did today is I put in a couple questions where I'm going to have you guys try to graph 2, and I'm going to have you label, again, just like I just did in the notes, and I'm going to have you write 2 equations, one where you're given the directrix and one where you're given the focus. Now, I didn't show you how to do a focus one, but I want you to try and figure it out on your own. You should be able to do that. So if you have any questions, just let me know, and we'll talk to you guys soon. Have a good one.